Okay, the weather attribution group, which includes scientists from across the world, although mostly the ones from Europe, has done an attribution study of the Pakistan floods of 2022 summer, which basically covered almost the entire country. They use statistical approach, so-called generalized extreme value theorem, and then they do use models where they compare pre-industrial probability of such a flood and how the current warming status, the warming levels of 2022 changed the probability of the occurrence and the rainfall amounts and so on. So the technical details are complicated, and the numbers of probability and so on are reported in findings. So we will go through the findings, but let's first look at some background material provided by the report as well, which is cited here. So this is a schematic diagram of 3 flood-bearing mechanisms during summer monsoon season over Pakistan. So you have mostly a lot of the moisture that is coming from monsoonal circulation. The main thing to remember is that the southwesterly winds veer to the west, to the east over to India, and the winds kind of get weaker on this side with westerlies, northwesterlies coming in on this side, and a lot of the moisture then tends to come from the Bay of Bengal, and the onset here happens in July, end of June into July, as opposed to June, May, end of May and June here, and then the trough progresses eastward. Elsewhere I have a podcast showing that the warming here has been caused in the northern Arabian Sea recently by the North Atlantic forcing, the Atlantic multidecadal forcing, and Western Pacific forcing related to the Atlantic multidecadal forcing. So that also can pump in some moisture here. And there are, of course, these low pressure systems. So category 2 floods. So this is category 1 flood, category 2 flood, and this is category 3 floods. So just kind of keep those in mind, and there are also reasons why these have started to go more towards the west-northwest direction, because the low pressure systems themselves have been affected by the circulation change. The southwesterly low level jet, for example, has shifted northward in recent times, reducing rain over Kerala, increasing it over parts of Maharashtra, Gujarat into Pakistan, the lower part of Pakistan. So that also adds to this misery, and then you have this third situation where you have low pressure systems coming across and then sweeping over large parts of Pakistan from the south into the north. There are lots of topographical issues here, and Pakistan is home to almost 7,200 glaciers. Obviously that means they are small glaciers but still critical, and there are a lot of glacial lakes. So glacial melting has created lakes which can lead to glacial bursts and sudden release of water. This was invoked as one of the potential causes, but this report in the models or in the statistical analysis does not include the glacial burst contribution, and argues that they were relatively small compared to the rains themselves. So here the movement of monsoon depression from Bay of Bengal across India and Pakistan during the monsoon season of 2022, and you can see, I don't know if you can read all the numbers, but 19th August, 13th August, 14th August, 9th August, 8th August, and so on. So many systems trudged across India, the core monsoon zone, all the way into Pakistan. So this is kind of fits into this one, I suppose, but obviously these are changing constantly as well. You can read the report for more details on the explanations and the papers that provide, or the sources that provide this categorization and the information. So these are from Pakistan meteorology departments. Okay, so there are, of course, there is a large-scale context to the rainfall anomalies. This is looking at the correlation between rainfall from the NOAA CPC dataset over July-August in the Indus Basin and correlations done with global SST product from ERSST for months of July-August, calculated over the years of 1979 to 2022. What is the main message? That cold temperatures here produce heavy rainfall over here, which is also true largely for India in terms of a La Nina producing excess rainfall over Indian subcontinent into Pakistan. On the other side, El Nino can tend to produce deficit rainfalls, but you also have already heard in other courses and podcasts that only 50% of the excess years and dry years can be explained by La Nina and El Nino respectively. So there is a lot of internal variability as well. And also the question is, how are the natural variability contributions being modulated by global warming, like the warming of the northern Arabian Sea, northward swing of the low-level jet, allowing low-pressure systems to go across, and the trends in the synoptic scale low pressure systems themselves. The 3 to 10 day low pressure systems are reported to have increased by Arindam Chakrabarty's group from IISc Bangalore, and the lower frequencies of 10 to 20 day, 30 to 60 day are supposed to have decreased. So obviously there are all sorts of changes, and the relentless warming goes on, of course. 2010 was the previous big flood in Pakistan that created a lot of havoc, made big news. So this is looking at mean sea level pressure and 2-meter temperature in the air, and 2-meter temperatures and mean sea level pressures from ERA 5 reanalysis. Basically the argument is that these contribute to producing cyclonic circulations and pulling in moisture from the Bay of Bengal and the Arabian Sea to create these massive amounts of rain. So you can see that this was, so you can see where this is. India is here, Bangladesh is here, Pakistan is over here. So this was centered more in northwest India. So the May heat wave or the excess warm temperatures lead to heavy rains in June, July. So that's invoked as one of the possible causes in May 2022 as well as for May 2010. These are the rainfall for two systems from Pakistan Meteorological Department from two events. So this is the 18 to 19 July, 18 to 19 August 2022. I have some sound in the background. Hopefully it's not too bad. So you can see that the average annual rainfall over Pakistan itself is around 500 millimeters, but some of these events crossed that annual amount here during this during these 2 days, and you can see the general rainfall anomalies being excess over all these. These are the stations shown in dots. So you can see there's a bullseye here with tremendous amount of rain compared to the expected climatological rain, and this is showing for 25 to 27 August 2022, and now it's focused on the western side of Pakistan, northwest and west. Here again rainfalls over 100 millimeter, at least 50 to 100 and maybe 100 to 200 millimeter range, which definitely count as extreme events, especially considering the background amounts. Okay, there is also a contribution for the mid latitude jet. You can see this is upper tropospheric circulation for 28 to 30th July 2010, for 18 to 19 August and 25 to 27 August 2022. So generally there is a relation between mid-latitude circulation, meandering of the jet stream. Arctic warming can send Rossby waves down here, which are invoked for late season droughts and extreme events here as well. Okay, so there is a global context to this, and the confluence of these things can produce the kind of deluge that was produced in 2022 this year. So this is the observed average 60-day rainfall for 1st July to 29 August 2022. So observed 60-day rainfall here. The red highlight, this region shows the Indus River Basin. This is the 5-day rainfall for 22 to 26 August 2022. The study region encompassing Baluchistan and Sindh is highlighted in red here. Okay, so you can see these amounts here in millimeters per day. May not seem like large amounts, 20 over 20, maybe much higher than that millimeters per day, but it had been raining heavily from June itself, and there was a massive heat wave in March, April, May. So everything added. Arctic is warm. Jet stream is doing its thing, producing all kinds of heat waves over Europe. So all these things come together, and the droughts in China is also record breaking, and so on. So there is a confluence of various things. Just to add a little bit here, various rainfall products looking at longer term rainfall distribution, and you can see that 2022 jumps out here way above anything that's been seen for a while. Similarly, this is the mean precipitation averaged over Baluchistan and Sindh, again jumping way above anything that's been seen in the last 70 years. So that's massive. This is just time series of annual average rainfall in millimeters per day along with 10-year running mean. So you can see even the jumps here at the end. ERA 5 doesn't capture it, so we have to be careful when we use the reanalysis product to interpret some of the processes, but nonetheless the data products capture. So here is Baluchistan Sindh, which is done better in ERA 5 compared to Indus Basin, but nonetheless you get the point that this is really a monstrous rain event that built up over time, which also points to human factors like not having proper drainage, groundwater soaking, groundwater recharge not happening because of various land use changes, and so on, right? Keeping all that in mind, the main findings of the report are that the flooding occurred as a direct consequence of the extreme monsoon rainfall throughout the summer of 2022, exacerbated by shorter spikes of very heavy rain, particularly in August, hitting the provinces Sindh and Baluchistan. We therefore consider 60-day and 5-day maximum rainfall during the monsoon season for the Indus Basin and 2 provinces respectively. The devastating impacts were also driven by the proximity of human settlements, infrastructure, so homes, buildings and bridges, and agricultural land to floodplains, so people are just closer to floodplains than they should be if planning was done properly. Inadequate infrastructure played a role, limited ex-ante risk reduction capacity, so they haven't planned for adaptation and risk reduction to such eventualities. An outdated river management system, so dam operations are always a problem. Underlying vulnerabilities driven by high poverty rates and socioeconomic factors, for example, gender, age, income and education, and ongoing political and economic instability. The report actually provides some vulnerability analysis, which I'm not going to include here because it's a bit of a digression from just reporting on the attribution. But one can easily imagine that the heavy rains were exacerbated by human activities to make the floods much worse. The return time for both events defined above is about 1 in 100 years in today's climate. Rainfall in the Indus Basin is, however, extremely variable from year to year due to, amongst other drivers, the strong correlation with ENSO cycle. Thus, exact quantification is difficult. So attribution is not easy, and the key part to remember is that 1 in 100 year event may begin to occur more frequently than once in 100 years because of all these factors. Continuing, first looking just at the trends in observations, we found that the 5-day maximum rainfall over the provinces Sindh and Baluchistan is now about 75% more intense than it would have been had the climate not warmed by 1.2 degrees C, whereas 60-day rain across the basin is now about 50% more intense, meaning rainfall this heavy is now more likely to happen. So this is an actual attribution giving percentage increases of intensity of rainfall at 5 days and 60 days. There are large uncertainties in these estimates due to the high variability in rainfall region, and observed changes can have a variety of drivers, including but not limited to climate change. So this is a caveat which has to be remembered. Overall, what is the attribution for? Okay, now you showed that climate change potentially made a contribution. Can we use this to get some compensation from the countries that are largely responsible for the 1 degree C warming? The loss and damage mechanism that is kind of being discussed and may take hold in some form is not completely working yet. So attribution eventually may be useful for those things if in fact there is an agreement on compensating for additionality of intensity of rainfall changes and so on because of climate change. So this region is prone to 1 in 100-year event. Is climate change making it more frequent? Can that be then used to claim compensation for the impacts? Secondly, to determine the role of human-induced climate change in these observed changes, we looked at the trends in climate models with and without the human-induced increases in greenhouse gases. This is the standard technique of doing attribution from models. The regions involved are at the western extreme end of the monsoon region, with large differences in rainfall characteristics between dry western and wet eastern areas. So eastern Pakistan is the tail end of the monsoon circulation and the Bay of Bengal supply through low pressure systems and mean circulation through the monsoon trough. So then the west gradually drops off. But even the wet areas on average only have 500 millimeters per year. Many of the available state-of-the-art climate models struggle to simulate these rainfall characteristics, so this has to be remembered. Those that pass our evaluation test generally show a much smaller change in likelihood and intensity of extreme rainfall than the trend we found in the observations. This discrepancy suggests that long-term variability or processes that our evaluation may not capture can play an important role, rendering it infeasible to quantify the overall role of human-induced climate change. So at this point, it's not possible to very accurately implicate human-induced climate change on the details of this event. However, for the 5-day rainfall extreme, the majority of models and observations we have analyzed show that intense rainfall has become heavier as Pakistan has warmed. So it's just relative change, pre-industrial versus current levels of greenhouse gases in the models do produce heavy 5-day rainfall events over Pakistani regions that we are looking at. Some of these models suggest climate change could have increased the rainfall intensity up to 50% for the 5-day event definition. Looking at the future for a climate 2 degrees C warmer than in pre-industrial times, models suggest that rainfall intensity will significantly increase further for the 5-day event, while the uncertainty remains very large for the 60-day monsoon rainfall. So keep in mind that the models have trouble simulating the distribution of rainfall here, and then keep in mind that there are uncertainties in future projections, and that Indian monsoon, for example, the historic trend is not produced by most models because of various reasons I have discussed elsewhere, and future projections are not dynamically consistent, and that's true for East African monsoon as well. So what do we do with the Pakistani projection here? Well, adaptation is the good strategy, of course. Our results are in alignment with recent IPCC reports. So this is like expect the best but prepare for the worst kind of thing. Both current conditions and the potential further increase in extreme peaks in rainfall over Pakistan in light of human-caused climate change suggest that there is an urgent need to reduce vulnerability to extreme weather in Pakistan. This is true in any case. So with the caveat that maladaptation should be avoided in terms of where to build the dams, where to plan for drainage systems for expected increases in intense heavy rains, more frequent, more duration, frequency, and intensity are what we always worry about. How to make plans for adaptation to reduce vulnerability and exposure so that overall risk can be reduced to these hydroclimatic hazards then requires additional socioeconomic calculations, population distributions, distribution of land use, continued urbanization, continued deforestation, continued drying, and so on and so forth. Okay, so I'm going to leave it here as a brief summary of this report, which makes several points about attribution, including how limited the models are still in terms of forecasting these events, and then even attribution of these events to climate change. Okay.